Welcome to Homework Lib.
Here we're going to have a block of a mass equal to 10 kilograms, and the forces that are acting on it are going to be the following. Over here, just to make it more accurate, and we're told that we're going to have a force pushing eastward of 20 newtons and a force pushing west of 15 newtons. Remember that additionally to that, we're going to have the force coming from the weight of the object. And since this object is not going to be floating, we're going to have also a normal force. So we know that the sum of the forces on the x-axis is going to be 20 Newton on the positive x-axis minus 15 Newton. So this is going to be equal to 5 Newtons in the positive x-axis. We can label this with the unit vector I, meaning that we're on the x direction, or we can state it in words like this is going to be 5 newtons eastward on this direction. In addition to that, we know that the sum of the forces on the y-axis is going to be equal to the force due to the weight of the object plus the force coming from the normal force. In this case, since we have this system of reference, this is going to be equal to minus mg plus the normal force. In this case, since the object is going to be staying on the ground, this needs to be equal to 0, so we know that the normal force is equal to mg, and the sum of the forces on the y-axis is equal to 0. If, for some reason, in your problem, the block is not on the ground, then there is not going to be any normal force. Let's say that we have just the block free falling. There's air. So in this case, the sum of the forces of x would be exactly the same. It would be 5 newtons on the I direction, or 5 newtons going east, or in the eastward direction. And the sum of the forces on y would be equal to minus mg directly. So it would be equal to minus 98.1 newtons going down. On this second case, if the block has no normal force, then the resulting force would be minus 98.1 newtons, and on this direction, 5 newtons. So we can find the sum of the forces, which would correspond to this vector over here. This would be the total force, and the magnitude would be equal to the square root of 5 squared plus 98.1 squared. The magnitude of this force is equal to 98.23 newtons. And the direction of the force, we can find it employing this angle theta over here. We have the value for the hypotenuse, we have the opposite catet and the adjacent catet. So in this case, let's employ directly sine of theta. So sine of theta would be equal to the opposite catet divided by the hypotenuse. The opposite catet corresponds to 98.1. And the hypotenuse, 98.23. So this would give us 0.999 arc sin of 0.999 is equal to theta, and the angle would be 1.526 degrees. Oh, sorry, radians, which is in degrees 87.43 degrees. So we could say that the total force would be of 98.23 newtons at an angle of 87.43 degrees south of east. So those are the two possible scenarios. In one of them, we have a normal force that is going to make the sum of the forces on y equal to 0. And in the second one, we only have three forces. There's no normal force. And the resulting force would be the sum of the forces on x and the forces on y. And the angle, we can find it as we did. So that would be all. Thank you very much and have a good one.